What is up, YouTube? Mr. Keen coming at you live. It's been a big hiatus for me. Sorry about that. Thank you to all my loyal subscribers. Here is what you're going to learn today. It is going to be one of the most life-changing videos you'll ever watch. Okay? Sadly or happily, you'll never look at the stars the same after today. So the essential question today is, why is the night sky called a sky full of ghosts? That's what you're going to learn about today. So in your notes, please call it Sky Full of Ghosts Notes. Okay? So we're going to review from the last video. The speed of light is 300 million, or 3 times 10 to the power of 8, in scientific notation, meters per second. So basically, light can reach 300 million, 3 with 8 zeros, 300 million meters in 1 second. So light's super fast. We never really have to worry about light not reaching us on Earth. But what about in space when things are really far away? So I want you to do, we're going to go back in time to the very first formula that you learned in this class. Speed, to calculate it, you take the distance something travels divided by the time it takes to get there. So speed is distance divided by time. But now I want you to get time. Please rearrange this formula and get time. Okay? Hopefully, you still remember some algebra. You can either swap the time and the speed, or you can multiply both sides by time and then divide by speed, and you will end up with time is the distance divided by speed. So that's the answer. Time equals distance divided by speed. Please write that down. So light is super fast, the fastest thing in the universe that we know of. However, it can still take a while to get somewhere because the universe is so big. So how long does it take the sun's light, to reach us here in Stockton? Okay, so if the distance from the sun is 147 billion meters, or 147 times 10 to the power of 9 meters, and the speed of light is 3 times 10 to the power of 8 meters per second, how many seconds will it take for the sun's light to reach us? Okay, please try and solve it on your notes. You will need a calculator with exponents. Say take the distance. I'll do it on here. Take the distance. 3 times, distance. So it was 147 billion. 147 times 10 to the power of 9. Power of 9. And because of order operations, divided by the speed of light. So that's how many seconds it takes to get the sun to get to Earth. 147 seconds, or 490 seconds. If you want to get it in minutes, you divide by 60, and you get 8.16667 minutes. Now, common misconception. You look at 8.16667 minutes and you think that's 8 minutes, 16 seconds. The issue is, this is a little confusing, but this decimals is out of 100. So that's all out of 100. But seconds are out of 60 to get to minutes. So if you want to see how many seconds it'll be, you take the proportion times 60, because it's out of 60 seconds per minute, not out of 100. So it's around 10 seconds. So 490 seconds comes out to 8 minutes and 10 seconds left over. And this makes sense because if you do 8 minutes times 60, you have 480 and then 10 seconds left over. Okay, so what that means, that is important because when the sun rises, there's actually an 8-minute, 10-second delay between the sun's light and what we see here on Earth. So, I know it's a little hard to grasp, but let's say the sun disappeared, just completely vanished. we wouldn't actually know because the sun's light from 8 minutes ago would actually still be on Earth. So there's always an 8-minute delay from when the sun does something to what we see on Earth. Because light is fast, but it's not super fast. So it still takes light 8 minutes to go that huge distance. Okay? And now we're going to learn what the consequences are with stars. Okay? So, you may have heard of Aries. I know astrology is getting really big, sadly. Aries is a constellation. So all the words in the zodiac in astrology, Aries, Sagittarius, Aquarius, all of those are all actually based on constellations. So I picked Aries because I'm actually an Aries. So Aries, the constellation on average, is a distance of 2.74 times 10 to the power of 18 meters away from Earth. So around 2 with 18 zeros meters away from Earth. So it's super far away. We get that number based on how bright the stars are. So that's how far away Aries is. And we know the speed of light is 3 times 10 to the power of 8. I want you to do some math, use this formula, try and find how many seconds will it take the light to reach us here on Earth. How long will it take Aries to reach us on Earth? So please pause the video now, do it on a calculator. I'll do it on here. Hopefully you did it yourself so you can learn. But here's what you do. 2.74 times 10 to the power of 18 divided by 3, the speed of light. So really big number. That's how many seconds it takes for the light from Aries to actually reach us here. It's kind of hard to grasp how long this is. So we're going to take this time, 9.133 times 10 to the power of 9 billion seconds, and we're going to convert it into years. So we're going to do another throwback. We're going to convert the seconds to years. So you have 9 billion seconds. You may remember the train track method. Maybe you don't. You could look at my YouTube video on how to do that. But what you do, you basically cancel out the units. So to get 9 billion seconds into minutes, you divide by 60. Now, what if you wanted to convert minutes to hours? How many minutes are in an hour? 60. So that's how you get into hours. Keep going until you get it into years. Okay, so keep going on the table until you end up with years. And that will help you get how many years away Aries is from us, the light. So if you keep going, you divide by 24 and then 365. So there's a couple ways you can do this. If you remember the train track method, you multiply all the top numbers divided by all the bottom numbers multiplied. So if you want to do it, you take 9 billion divided by all the bottom numbers times each other. So that's the way I did it. You take the top number, all the top numbers multiplied, divided by all the bottom numbers multiplied. And you will get 289.6 years. There's another way to do it though, if you're curious. So you have 9 billion seconds. If you want to convert seconds to minutes, you divide by 60. Now that's how many minutes away Aries is from us. Divide by 60 again, 60 minutes in an hour. That's how many hours away Aries is from us. How many hours in a day? 24. And then how many days in a year? 365. That is another way to do it. That is the same thing as the train track method. Yeah, so I just kept dividing until I got years. So it takes Aries, the light from Aries, 289 years to actually reach us here on Earth. So that means if it takes that long for Aries to reach us, then what are we seeing right now? When we look up at the sky, what are we actually seeing? It's actually Aries from 290 years ago. What you see up at the sky is old. It's not actually there right now. It might be, but the light that's hitting you on Earth is actually 290 years ago. Because that's the delay, since the speed of light isn't infinite, the speed of light takes 290 years to get here. Okay? So, if the light from Aries is 290 years away, do you want to guess what this is called? It has to do with this picture. So, if the light from Aries is 290 years away, it is called a light year. So, if you look up how far away is Aries, it won't say the distance. It'll just say Aries is 290 light years away from us. So, a light year is both a unit of time. So, it's actually how long it says years, so it's how long it takes for Aries to reach us, but you could backwards calculate and figure out how far away Aries is. Okay? So the light from Aries is actually 290 years old. That's what we see. It's 290 years ago. So we can't see what Aries looks like right now. We can't see what it looks like. We have to wait 290 years to see what it looks like during the recording of this video. Okay? Now, here's another example. Distance, remember, is divided by speed equals time. So time equals distance divided by speed. The speed of light is 300 million. Let's say you see a shooting star. Scientists say happened 7.41 times 10 to the power of 20 meters away. So that's how far away the shooting star occurred. How many years ago did the shooting star actually happen though? Because remember, if it's far away, it'll take the light a long time to actually get here. So if you see a shooting star tonight and it's this far away, how long ago did this shooting star actually happen? And I do want you to convert it to years. Okay? So please pause the video now. Try and get the answer. If you do it 7.41 times 10 to the power of 20, that's how far away the comet is. And you divide it by the speed of light. So 2.5, roughly, trillion seconds. That's a lot of seconds. If you're curious how long that is in years, using the Turing Tech method, 60 minutes in an hour, 60 minutes, seconds in a minute. So that's in hours, not 24 hours in a day, 365 days in a year. So that's how long it takes light to get here from that distance. So according to this, the comet that you're seeing actually happened. It already happened. You missed it. It happened 78,000 years ago. Okay? The reason is because it takes light 78,000 years to actually get here. So here's showing how you did it. You take the distance divided by time, the speed. Distance divided by speed equals the time. And then you convert the seconds to hours, to days to years. And you get 78,323.2 years ago. So it might be a little sad. It was sad when I learned it. But when you actually see a shooting star or a meteor shower or stars in the universe, some of them aren't actually there right now. And all of the light that you see is old. Most of the stars are old enough where they'll actually still be there, but some of the stars aren't actually there right now. Or like the shooting star that you see. It didn't actually happen while you were watching it. You're watching a ghost of the past because it happened a long time ago. It just took us a while to actually see it because light takes time to travel to us. And that is why the sky is full of ghosts. Because what you're seeing is actually a snapshot of the past. Because it takes light time to get here. Yep. Thank you so much for staying with me the whole time. I hope you enjoyed the video today. I spent a lot of time on it. Thank you so much for watching. Have a great